To speak up as you have questions. Okay. So we're in chapter 1. There's the picture of our book, Elementary Statistics, that we'll be using, that you'll buy for that $60.50. You don't need a physical book. I was clear on that, right? The book's all you need is the online license. The book will be online. No physical book. All right. 1.1, statistical and critical thinking. Key concepts. So here we go. I don't think you need to write all this down. Yeah, let me say that real quick. I'm going to go too quick, really, for you to write everything down. This will all be on YouTube later. I think you write down whatever you want to write down, maybe the gist of things. But I try to, because that's why I spent time on Christmas break to say, how can I, because 15 years ago when I taught this class, way back I was at Stanislaus State in Turlock. When I taught it 15 years ago, I taught about 10 or 15 times back then. But it's been a long time, and technology has changed a lot, and I've started using an iPad in the last 2 years. So I thought, okay, how can I do this in a way that's easy for me it's to present, so I don't have to write everything on the board. It's easy for them, so I don't have to write everything on their paper, and yet we can still talk about it. Because there's a bunch of words. This isn't like algebra, where it's just 3x plus 2 equals 7, solve for x, you know. There's a ton of words. You'll see as we do the problems. There'll be paragraphs and paragraphs. And I don't want to write all those on the board, and you don't want to write all those on your paper. So what I'm going to do, I'm going to ship this onto YouTube, as I said. And I'm also going to email you, probably email or put on Canvas, I don't know, whatever's easier for you, the lectures ahead of time. I just mean the text. So you'll be able to grab it on your phone if you want to, or grab it on whatever, and it'll be right there. So you don't need to feel a burden to like write every word down. You'll have access to it. So when you're going back to do your homework tomorrow or whatever, and you go, what did he say about that? Just boom, it'll be right there. You know, there'll be a YouTube, and then I'll email you the text. All right, that's the plan. So anyway, I'll read this stuff, but don't feel a burden to write it all down. The process involved, so basically there are 3 things that are important there. I'm not just going to go read it boringly. It's just those 3 things. That's all we care about. Prepare, analyze, conclude. Those are the 3 things we're going to see. So let's go into data. Data, you know what data is. It's collections of observations. So let's get particular. Statistics. What is statistics really? It's the science of planning, obtaining data, organizing, summarizing, presenting, analyzing, and interpreting those data. So as we saw, this is statistics that I put on the board about the different studies. A lot of statistics is what does it mean? Therefore, what does it mean? All right, population. What's a population? Population is all measurements in consideration. Everything being, it's the complete collection of all measurements. As opposed to, let me do the next screen. A sample. Well, yeah, let me do it this way. There's a census and a sample. So here we're getting into some words. I'll go a little slower here now. These are more important words. So I would write that down probably. A census is a collection from every member of the population. So census is every member. Whereas a sample is just a sub-collection. It's just some of them. So in other words, like, what do we do every election year? They poll. They want to find out who's going to win the election ahead of time, right? So what do? They're trying to figure out the census. That's what we do on election day, right? On election day, they find out what everybody voted, right? Everybody who's going to vote goes to the voting booth and votes. So that would be on election day. That would be a census. That's the, every result. But ahead of time, those pollsters go crazy for a couple of months before election time doing what? Samples. So that is a poll, like a poll before an election. So what do they do with a poll? They take a small group of people, they grab a group of people, and they say, hey, who are you going to vote for? And they record those results, and they use that to predict what's going to happen in the actual election. That's a lot of statistics. Looking at a sample to figure out something about a census. That's a lot of what stats does. Look at a little group to figure out something about the big group. They do that in medicine, right? They want to figure out if a new drug is effective. So what do? Just start randomly giving it to everybody? Say, we're hoping for the best here. No, they use statistics. They grab a sample. They try it on a few people that are willing. They sign releases and stuff that are willing, usually to get it free in those first group of people. And then they look at the results. And they use statistics to determine if the thing's working or not before they go big time with it, right? I think one of the most famous cases of that is when they wiped out the smallpox vaccine back in the 60s or the 50s. I don't remember exactly. Anyway, smallpox used to kill people. It used to kill children, especially. It was really, it caused polio. It was a big problem back in the day. So they got a big sample and they grabbed a bunch of people and they actually had two groups. We'll talk about that kind of an experiment where you have two groups and they gave it to some, didn't give it to others, and they measured the results and they said, hey, it's working. And then they gave it to everybody. So that's what statistics is about. It's about doing something with a sample to make a conclusion that'll work for everybody, for the census. It's about getting to the truth about what's working. All right, let's keep going. So here's an example. Residential carbon monoxide detectors. You don't need to write all this down. Just get the idea here. This will be on YouTube. In the journal article, Residential Carbon Monoxide Detector Failure Rates, by the way, most of the data, I think it's like 92%. It's part of why I like this book that we're using. It's real data. It's not just made up stuff. It's real data. It was stated that 38 million carbon monoxide detectors installed in the U.S., when 30 of them were randomly selected and tested, it's a sample, right? It was found that 12 failed to provide an alarm in hazardous carbon monoxide conditions. So they're trying to figure out, are these things working? So there's 38 million total in the United States. They grabbed 30. So what's that 30? Yeah, that's the sample, isn't it? They grabbed a sample of 30 and found that 12 failed. What's the 38 million then? That's the census. That's all of them. So you getting the idea? And that's the population. That's, I didn't do that right. That's not a census. That's the census would be the results of all 38 million. We don't know out of all 38 million how many are work and don't work. That would be the census. Because census is when you find something out about the population. Getting the idea? Population is the total thing. So the 38 million is the total population. So there we go. The population, 38 million, the sample, the 30 they grabbed. So that's a lot of what we do in stats. Sample to determine the truth about the whole population. Now, yeah, you can look at that later. That's basically just saying those three steps. You prepare, you analyze, and you conclude. Let's dive into an example. So here we go. So we're going to walk through those steps. So here's the prepare step. Pleasure boats and manatee fatalities from boat encounters. Again, real life data here. Pleasure boats. This is in Florida. Yeah, Florida. Pleasure boats in Florida, tens of thousands. 99, tens of thousands. So how many is that? Yeah, let's talk about that. How many actual, when they say pleasure boats in tens of thousands, and then they say 99, how many exact pleasure boats is that?
990,000.
What is it?
990,000.
Yeah, good. Because it's 99 times 10,000. Right? 99 times 10 is 990. It's 990,000 pleasure boats. Does that make sense? How we figured that out? Because they're saying these are in tens of thousands. So 99 times 10 is 990,000. So basically, in some year, when there were 990,000 pleasure boats in Florida, there were 92 manatee fatalities. You know what? I had to look it up. And then I realized I'd seen it before. You guys know what a manatee is? How do you describe it? It's like a seal thing, right? Like a walrus, seal thing. I'm not a biology expert. So it's like some kind of seal thing. And it's in the waters. And so basically the boats are crashing into the manatees and killing them. Actually, I looked this up because I was like, what is a manatee? I didn't even know. And then I'm like, oh yeah, I've seen that on something. Anyway, and it said, the studies show, it confirmed this is true, that basically the pleasure boats are crashing into the manatees. It's not the propellers. That was the interesting part I read. Because I thought it would be the propellers or chopping them up. That happens a little bit, but it's mainly just simply crashing into them. So anyway, so here's a study. They're trying to figure out, are the pleasure boats causing manatee fatalities? So they got some data. So how many manatees died? This is how many, etc. So we got some data there. So this is in Florida. It suggests a relationship. Of course, we're going to get the statistical tools later. Right now, we're just getting warmed up. But later in the course, we'll have some ways of analyzing that. Saying, hey, is that really causing it? How do you know? Maybe it's just luck. How do you know? Doctors wonder that, right? If you got a new treatment and you give it, for cancer or whatever, or something less serious than cancer, and you give it to 100 people, and it seems to work on 63 of them, and the old treatment only worked on 50? Is the new treatment better? Maybe. Maybe it was luck. Maybe this was a healthier group. How do you know? Well, you figure out what the chance of luck is, and that requires statistics. And that's exactly what people do in the real world. There's something called a level of significance. You basically end up finding out what is the chance it was just luck. And if the chance is really small, then you don't believe it was luck, you believe the treatment's really bad. If the chance of luck is high, you just think, well, who knows, maybe it was just luck. So that's the kind of thing we're going to learn to do. Is how do you know when numbers given to you are really meaningful and should be trusted, or maybe not trusted? How do you know? And that's coming later. All right, let's move on. The second one, here's the same thing. You would need to measure the source of the data. This is from the Florida Department of Highway Safety, so there's always that, right? You want to make sure your information's reliable when you're doing a study. And then the sampling method obtained from the official government, like how did we get that information? Official government records, at least this one anyway. So it's reliable information. So that's the preparation stage. Next, voluntary response sample. Yeah, this is interesting. This will be a real application that we see all the time today. A voluntary response sample, or self-selected sample, is one in which the respondents themselves decide whether to be included in the study. So that's probably worth thinking about for a second. So voluntary response. So you can just write the words and you got it. Let's look at the examples. The examples are always the most helpful. Voluntary response samples. So here's some examples. Internet polls in which people online can decide whether to respond or not. Mail-in polls in which people can decide whether to respond. And telephone call-in polls. They don't do many of those anymore. So what am I talking about? Well, suppose you're online. In fact, let me jump ahead. Maybe there's some example here. Yeah, there we go. Nightline. Okay. Nightline asked viewers to call with their opinion about whether United Nations headquarters should remain in the United States or not. 67% of the 186,000 respondents said the UN should be moved out of the United States. Okay, and then they did a second study. Down here, they asked 500 people if the UN should be moved out of the United States, and only 38%. That's wildly different. Only 38% wanted it moved out of the United States. So which one's true? Which one's really the people's opinion? That's what I mean by true. What do the people really want? What do the people of the United States really want? This study said 67% of them say, move it out. This study said only 38%, a very small group, or less than half anyway. This is more than half. Which one is it? Well, which one of those studies should we believe, and which one should we not believe? Which one has something shady to it that tends to twist the truth, not get you to the real truth? Any ideas?
500. They randomly selected the survey.
Yeah, what's the problem with the 500?
They randomly selected and surveyed people they picked, or the other ones responded. They chose to respond.
Well, randomly.
Right.
So if I was to go up front and get your list of 30 names and roll a die or do something where I could randomly pick a name. Say, I just feel a job. I'm going to give away $10. And I was just to roll a die and go, okay, it's this person. Hand $10. Did I really pick that person? If it's done randomly, did I really do it? Not really. The dice did, right? It was random. So random means random. It wasn't them picking, right?
500 is a lot less than 100.
500 is a lot less. What about that? Than 186,000. So maybe that's the reason we should doubt this one. What about what we said about voluntary? What do you think about that?
The voluntary, those people who volunteer most likely are into the topic, so they want to put their input, so you're more happy have
Credibility.
Yeah. Really, you should believe the second study. Even though it's only 500 people. 500 is enough. We'll talk later about how do you know because I only asked 3 people, right? And 2 said yes, or that's not enough. And we'll talk about, basically it's the chance of luck. We'll talk about how do you know when it's too few people. It all has to do with what the chance is of luck. You're only asking 3 people. Yeah, you could easily just got a random weird 3 people that had a strange opinion. But 500, that's pretty reliable. That's plenty. You're getting the truth with 500. You're going way up to 186,000, that won't change much. 500 is plenty. Anything 500 or more, really anything 100 or more in this situation is fine. There's no way you could just get a lucky 500 people. This is not going to happen. I mean, it could, but it's very unlikely. More likely to get struck by lightning 3 times as you're going out to survey them. It's super unlikely. Or win the lottery twice, right? So very unlikely. So the problem with the first study is it was voluntary. See what they said? Nightline asked viewers to call with their opinion. So in other words, a bunch of people watched that show. Most of them said, whatever, I got things to do. But a few people, well, 186,000, that's quite a few, to whom this is really important, one way or the other, for or against, this is a big issue to them. Because they took the time to call in. I mean, have you ever called into a show?
Long wait.
Is there a long wait? Yeah, you must care about it. I've never called in. I just guess I don't care. But yeah, I mean, if you're willing to call in, you care more. Which means what? You're not average. We're getting the people that are not average. We're getting the extreme people. That's what we're getting. One way or the other, for or against. We're getting the extreme views. People willing to call in, to take their time to call in. Whenever, so you want to watch out. This is what you see all the time on the internet, on the TV. They'll say, blah, 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 call in with your opinion. You should just disregard. Those results are bogus. Whenever they say those kind of things, they might as well they're making up fairy tale numbers. Because all they're getting is the opinion of the extreme people. They're not getting the opinion of the average Joe or Jane on the street. Those people don't bother to call in. You only get that when you randomly select. Because then you're getting everybody. You're getting the regular people, the extreme people, you're getting it all. You've got to randomly select. If you do anything where they volunteer, they call in, they respond, internet says, click on this and tell us your opinion on who should be the MVP of the NFL this year, or whatever, ignore those. Those results are not really the opinion of all the United States or whatever their population is. It's just the extreme people's view is all you're getting in that situation. So, yeah, even though it's dramatically different, the much smaller pool of 500 is more likely to produce the results because it's a superior sampling method. So how you gather the information really matters to how likely you are to get to the truth. All right, so that's the first thing is preparing the study. How you gather information really matters, and we'll talk more about that in days to come. Next, you got to analyze the information. So once you've got the information, once you've surveyed randomly or however you surveyed, then you got to analyze it, and you don't need to write all that down. We'll get into particulars. And then you got to draw a conclusion. Once you use some statistical method to analyze it, and that's what this course is all about. Once you've done that, you've got to decide, what does it mean? What does it mean? There's something called statistical significance. That's like I was saying, if the likelihood of an event occurring by chance, luck, is 5% or less, that's the general standard in the world, period. Everybody that uses stats, medical science, name the field. Anybody that uses stats, it's generally considered reliable, significant, noteworthy, to be trusted if the chance of luck is 5% or less. That's what's usually used in the world. So if something has a 5, because anything can happen by luck, right? I could go outside and just randomly grab, 20 people and ask them, what their favorite color is, and they could all say blue. That could happen. Now if I grabbed 3 people, it's more likely that they would all say blue. If I grabbed 20 people at random and all 20 say blue, and then I kept going and there were 50 more, and every single person I talked to said blue, I would start thinking that there's something weird going on in the world, right? That these people have talked beforehand. It is not very likely that I'm going to talk to 50 people in a row that are all going to say their favorite color is blue. You get the idea. The more people you do, the less the chance that things are just luck, right? And we'll get tools to calculate all that. But in general, if the chance of luck is 5% or less, we consider that statistically significant. All right, so yeah, let's look at their example. They have good examples here. 98 girls in 100 births is significant because that's not likely. So these the different methods they now have, because couples want to have a boy or they want to have a girl, right? So there's different medical things they can give them to make it more likely to have a girl or more likely to have a boy. So how do you know if those are working? Well, what if you have a certain treatment and when that treatment's done, 100 births, 98 are girls. Seem like it's working? Well, yeah, for sure. I mean, that can't happen by luck, right? I mean, it could, but yeah, like I said, not very likely. It's like the chance of being struck by lightning. It's not very likely. So if you get 98 out of 100 girls, you're thinking this thing is working. Whereas down here, what if you get 52 girls out of 100? Think, oh yeah, we did this treatment, and look, it was more than half. Well, yeah, just barely. That could have just been luck, right? You could 52, you can just get that by luck. That doesn't mean the treatment's working. It might be working, but that certainly doesn't give me any confidence it's working. That's not statistically significant. Making sense on that? So practical significance, that's another issue. So there's statistical significance, less than a 5% chance of luck. And then there's practical, like what does it mean? What does it mean? Let me look at an example. Let's look at an example. They have a good one right here. This is a very good one. All right, so ProCare Industries once supplied a product named Gender Choice. This is real life information. Gender Choice that supposedly increased the chance of a couple having a baby with the gender that they desired. In the absence of any evidence of its effectiveness, the product was banned by the FDA as a gross deception of the consumer. That's what FDA is all about, statistics and whether things are really working or not. What's that product? Airborne. That's right, Airborne. You guys, know about that product that helps. What does Airborne do? It helps reduce, it strengthens your immune system so to shorten the span of getting sick or staying sick. Or it's supposed to prevent.
It's supposed to prevent.
Prevent more than help you afterwards. Yeah. And so I remember, I was kind of crazy with that whole thing. So I used to.
Made by teachers.
Yeah, made by teachers, right? So I was a teacher. I thought, this is for me. So I was taking it. It was like 5 years ago. So I was kind of into it for a while. I was taking it. I remember my oldest son one day mocking me. He does that. I think he just takes pleasure in that. Anyway, and he's like, Dad, come on. The statistics, the study, they've shown that, the FDA, I think, they could not prove scientifically that it worked. I don't know how to say that well, but basically the FDA, if you look on the side there, and I checked it out, I grabbed the bottle, looked at it, and he's right. Airborne has not been proven to work. They tried, they tested. There's no statistical evidence that it really works. So anyway, I was done with it. And I used to take it late anyway. Once I get the cold, then I start downing it. And my wife was like, that's too late. Anyway, so I had several problems with Airborne. But I remember after he told me that, I just quit it. And he's right. I mean, it hasn't made, it never seemed to make a difference for me anyway. I know some people, my wife's mom swears by it. But my son, I'm sure, mocks her as well. But anyway, there's no statistical evidence that it, and so that's what for FDA to approve a drug for treatment, it has to be proven to be statistically significant to really do something. So you can buy Airborne, but you notice they have, if you read the side, they're forced to put on there no evidence that this really works. They have to. It's on there if you read it. Anyway, so let's take a look at this example. So FDA is into this a lot. This actually happened with this Pro-Choice Industries. Coming on down here. Suppose that the product was tested with 10,000 couples who wanted to have baby girls, and the result consisted of 5,200 baby girls out of 10,000. What do you think? Does that sound good? The result is statistically significant, because the likelihood of that happening by chance is very low. Right? I mean, if this treatment is doing nothing, you get what I'm saying there? If this treatment really is not working, then we would expect exactly half of the 10,000, 5,000 girls. But they got more. They got 5,200. Where's the number? Oh, there it is. 5,200. So they got more than half girls by 200. That's a fair bit. You tracking with me? You understand what that's saying? So they got 200 more girls than we would expect. Now, could that have just been luck? Not very likely. 0.003% chance of luck. So it seems like it's working. It's making more girls. So then why did the FDA close them down? Are you tracking with me? That'd be the natural question. Right? That's statistically significant. That can't be luck. It's very unlikely. That treatment's doing something. It's making girls more likely. That can't be luck. Well, then why'd they close it down? Well, yeah, it's making girls more likely, but not much more likely. It's making girls 52% likely. That's only a little better. So it's not practically significant. Do you understand? Yeah, it works. It works. It raises the chance of you having a girl. Actually, the chance of having a girl, if you know, is 48.8. That's the real. Girls are less common than boys. Did you know that? Learned something today, huh? 48.8%. Girls are less common than boys. I like girls, my little girls. They're sweet. Anyway, I've got 3 of them. The boys, they smell. No, I mean, I like my boys too, but girls are sweet. Anyway, so, yeah, girls are actually a little bit less likely than boys. 48.8% is actually of our population is girls. So it did raise it, and that can't be luck, but that's not raising much. Do you get the idea? That's not practically significant. Even though, did it do something? Yeah, for sure it is doing that. I mean, that can't just be luck. It did raise it, but it did, they don't want to, you wouldn't want to spend a bunch of money and have medical treatments just to raise the chance of having a girl by that amount, right? That's not much more likely. So is it doing something? Yes. But is it doing something significant? No. It's doing a little thing. So that's why the FDA got rid of it. Although it is doing something, it's not doing much. We good? This all making sense? All right. It's homework time. That was lecture. Let's do homework. So I'm on to the homework now. So I'm literally going to do your homework with you. It'll change the numbers for you, but it's basically the same. This is the Math Excel homework. So that was the information. Here comes the homework. How are we doing on time? Good. All right. So this is question number 1. Again, you don't have time to write all these down. They'll be on YouTube. This is when I say I'm going to mail you something, I'm going to mail you all this text. From now on, I'll probably ahead of time. I'll just ship it, email it, or put it on Canvas. So you have all this text, and then the actual lecture will be on YouTube as well after the fact. But I'll send you this ahead of time so you just have it on your phone and stuff. Okay, so here we go. Here's question number 1. A newspaper posted this question on its website. Can you read that? If I make it bigger, it's going to go off the screen. So that's why I want to send it to you so you can just look at it on your phone. So newspaper posted this question on its website. How often do you seek medical information online? Of 1,072 internet users who responded, 38% of them said frequently. So what term is used to describe this type of survey? Blah, blah, blah. So, all right, so here come our options. So what term is used to describe this kind of survey? So you get the idea, right? Online, on a website, a newspaper's website, they asked, how often do you seek medical information online? 1,072 internet users who chose to respond, 38% said frequently. All right, here we go. What term is used to describe this kind of a survey? Is it A? The respondents are a self-selected sample. Yeah. Right? Do you get the idea? They were not randomly chosen. That's how you get to the truth. You randomly pick people and ask them. You don't just say, hey, who wants to answer? Because you get the what? The extreme people. The people that are highly interested in that topic. So yeah, that's true, but it's select all that applies. There's more than that. How about the next one? The respondents are a census. Are the respondents a census? What's a census? That's everybody. Remember, census, when they take the U.S. Census, that means everybody in the United States. So that's no, this isn't everybody. This isn't everybody in the world. They're a population? No, that's not. Remember, population means everybody. The respondents are not a population. The population is everybody that saw that question on the internet. Not everybody responded, right? So the population didn't respond. Does that make any sense there? Do you see the difference between the population is everybody that saw the question. Not everybody responded. So the respondents are not the population. The respondents are a voluntary response sample. That's also true. So they're self-selected and they're voluntary, aren't they? So what's wrong with this? Select all that apply. Many people may choose not to respond. That's true, and that's a problem because they do have an opinion. They're just not extreme enough to respond. So you're not getting their opinion, and they have an opinion. B, the survey question is loaded or intentionally worded. No, it doesn't seem to be. There's no weird words in there. C, response may not reflect the opinions of the general population. Yeah, that's also true. You're just getting the extreme view. You're not getting the general population view. D, it's too expensive, 2 times 2. No, just A and C on that. Is that making sense? See how to analyze that? And see how that just went, and they do this all the time, don't they? This is real life. This is what we see in the 21st century all the time. Those are just not trustworthy. That's not the truth. It's not true to say 38% of all people feel this way. No, 30% of the extreme people feel that way.
So why wouldn't the respondents be a census?
Because it's not the whole population. So census always comes from the whole population. So if somehow we could know what everybody who saw that thing thinks, we got a track on their mind or something, and everybody that saw that question, boop, we have their thought, that would be a census. That would be the thought of the whole population. So census is always the result from a whole population. Okay, so good. So that was question number 1. Number 2, I don't know, I'll read this to you. It's pretty small and I can't blow it up. When testing a new treatment, what is the difference between statistical significance and practical significance? That's the question. Statistical significance and practical. Can a treatment have statistical significance but not practical? Is that possible?
Yeah.
We saw an example of that, didn't we?
Well, birth one.
The birth one, yeah, whatever it was called. Yeah, the birth one, right? It did move the chance of having a girl up to 52%.
Percentage wasn't high enough.
But that's just not practically a big deal, right? So yeah, that can happen. So I don't know if I want to read all those words. So what's a way we can cut through? That's a lot of reading. I don't know. I guess I just got to start. Statistical. This class will have a lot of words. It's all words here. Statistical is related to whether common sense. No, that's practical. That's practical. So that one's out already. Do you see how I eliminated that one? Practical significance is the one that's common sense. Like it's common sense that 52% is not a great improvement, right? Let's try the next one. Statistical significance is achieved when the result is very unlikely. Yeah, that's right. That's what statistical significance is. Very unlikely to be by chance. That's true. Practical significance is related to whether common sense suggests, yeah, so far so good, that the treatment makes enough or of a difference to justify the use. Yeah.
I have a question about that.
Yeah, question.
You said it was a common consensus that it was 5% that rules out chance.
Yeah.
And if it would have been more than 5%, then it would have had a practical significance.
Okay, yeah, good question. Yeah, so the 5% is the statistical significance, not the practical.
So
Really good question. Yeah, so when I...
the measure of practical significance.
Yeah, so let's talk about the girl. Let's go back to the girl one again real quick, the baby girl one. Yeah, that's good. Yeah, so back here we said, here, this means it's statistically significant because the chance that it was just luck was very low, 0.003%. So that treatment was certainly doing something. It was. It wasn't just luck. It had to be the treatment making that. That could not have happened by just luck. That, that 5,200 baby girls were born instead of, 5,000 or maybe less than 5,000, which you would normally expect with no treatment. That's 200 more than you would expect. That can't be luck. So that's statistically, so the 5% rule is for being statistically significant, right? That's back here somewhere. There it is. Less than 5, statistically significant, less than 5%. But that's not practically significant right here because that's just not practically a big deal. Only raising from 48.8 to 52.
So is there a norm for practical?
Yeah, there's not. Yeah, good question, huh?
That's what I think that's what you're asking. Is there a norm
Yeah,
for
I
both?
see. Good question. Yeah.
If it's more than...
There isn't. There really isn't. Yeah.
So you would have to have like a,
Right. They're going to make it really obvious.
Like
It's
if it was like 60 or something.
yeah, 70, 80. Then we go. Yeah. I won't try to trick you on the test and go, oh, it was 59, you should have thought. No, that'd be dumb. I'm not going to do that. No, it'll be really obvious. Either like it goes up to 80%, so that's doing something,
Okay.
or it's just right in the neighborhood, 3 or 4% away. That's not significant. Yeah, good question. Yeah, it just didn't move it enough, right? Okay, so it was B on that one. This one, it just says the correct answer, not all that apply. So I'm just going to find the good one and I'm done. I don't want to read all the rest. They must be bad. That good? So if it's a test, though, you would read them all, right? So I hope. Does that make sense?
Yes.
You want to be a good test taker. I run into students sometimes, and I'll talk to them after a test, and they'll go, yeah, I just read this and I thought it was good. And they're like, you didn't read this other one? You know, and so you want to read them all. On a test, you want to read them all and be sure. Those words can trick you. So, but in the interest of time, I will keep moving. Number 3. So determine whether the source given below has the potential to create a bias in a statistical study. Let's talk about bias. A certain medical organization tends to oppose the use of meat and dairy products in our diets. And that organization has received hundreds of thousands of dollars in funding from an animal rights foundation. Pretty obvious, huh? They're going to have a motive that's for something other than just what's true, right? They have a motive to oppose, if it's an animal rights foundation, they're going to want to oppose the use of meat and the use of dairy. So let's see, choose the correct answer. There does appear to be a potential, yeah. So, but the first two both say there does appear. This one says not, so C and D are out, huh? I don't know, can you read all that? C and D both have a not in them. There does not appear. Those are out. It's not C and D. It's either A or B. Good so far? Now let's see, I don't know which one it is. So there does appear, okay, now what's there is? There is an incentive to make the results insignificant? No. They're trying to, there's an incentive to make them, so that's not A, it's B. Do you see how they said insignificant here? There's not a motive to make them insignificant. There's a motive to make them significant. They want to make it seem like it matters, right? That's their motive. There is an incentive to produce results that are in line with the organization's creed and that of its fundraisers. Yeah. Make sense? So this class is a little different than normal math class, isn't it? It's a lot of words, not as much number pushing, which I think is interesting. I like it real like this, but just want to let you know this is the way it'll be pretty much on through. All right, so determine whether the source given below has the potential to create a bias. Here we go again. Washington University obtained word counts from the most popular novels of the past 5 years. So they're keeping a track on word counts of popular novels. Washington University. Any bias there?
No.
Yeah, I don't see any. And they'll make it obvious. You don't need to be super tricky. Well, maybe. You don't need to be a conspiracy theorist. It'll just be obvious, and that there's no obvious bias there. It's just a university. They're just counting words in books. They're not the publisher or something like that. That might have a motive one way or the other. So let's see. There does not appear to be a bias. Yeah, that's right. There does not appear. So it's either A or B, huh? Let's see which one. The organization is reputable and has many professional and credible members. Yeah? The university? Sure they do. What does B say? The organization would not gain from putting a spin. Wait a minute, they both seem good to me. Yeah. I see. Good thing I read on. It's not A. I was bubbling A in there. A's sort of true, but it's not the best truth. Yeah, that's where this is a little more fishy, this subject. Now, why is it B instead of A? Do you see why B is a better answer?
Answer the question. Answer the question.
Yeah, it's not about whether they're reputable.
Right.
Reputable people can have bad motives and bias, right? It's about whether they would ever have a bias. They have nothing to gain. That's the issue. It's not whether they're reputable, right? So see how I almost got the wrong answer by not reading the other one? So you want to do it on a test. All right, so number 5. An article noted that chocolate is rich in, I don't even know how to say that, flavonoids? Have you heard of that word before? Flavonoids, yeah, that's better. The article reports that regular consumption of foods rich in flavonoids may reduce the risk. Is that a real word? Is that Google? Is that a real word? I'd like to know. It's like they're making that up. May reduce the risk of coronary heart disease. The study received funding from a candy company and a chocolate manufacturers association. So, is there a bias? Of course. So, which one's the right answer? The researcher A says the researchers may have been more inclined to provide favorable results. Yeah, that's sounding good so far. Because funding was produced by a party with a definite interest. Yeah. The bias could have been avoided if the researchers were not paid by the candy company. Wait, were they paid? Did it say they were paid?
Yeah, study received funding.
Oh, you're right. Where is that word?
The study received funding.
Oh, there it is. Thank you. Study received funding. It looks like A to me, but let me read B to B because I messed up last time. Let me read B to be careful here. So on B, the questions used in the study might have, no, not the questions. That's dumb. Since the sample is no, it's not. It's not self-select. There's nothing in there said it was self-selected. The data do not seem to support the claim. We don't even know what the data are. No, it's that. Make sense? They didn't show me the numbers, right? Those are all bogus. All right. 6, determine whether the sampling method is sound or is it flawed. Survey of 692 subjects. Each was asked how often he or she played sports. The survey subjects were internet users who responded to a question that was posed on a news website. So what do you think?
Flawed.
And why is it? So it's one of these flawed ones. There's 3 of them, though. Why is it flawed?
Voluntary?
Because it's voluntary. There it is again. And it's just the correct answer. It's just one answer. It's that voluntary. They just keep beating that same drum, right? Voluntary studies are bogus. Number 7, a survey of 691 human resource professionals. Each was asked about the importance of the education of a job applicant. The survey subjects were randomly selected by pollsters from a reputable market research firm. Is it flawed or is it, I don't know if it's so small if you can even read those words. Is it flawed or is it good? Is it voluntary?
No, it's randomly selected.
Yeah, randomly selected. Yeah, it appears to be good. That's a good study. They're going to get reliable results because they randomly selected people, so they're not just getting the extreme views that you get with a voluntary sample. Yeah, that one's good. All right, number 8. Can make that a little bigger now. Well, it doesn't do anything on your screen. Okay, a magazine which does not accept free products, so they do not accept free products or advertising from anyone, prints a review of new cars. Are there sources of bias? No. They're not taking any money. They have no bias. There doesn't appear to be any bias. All right, I think these will be pretty easy for you. Number 9, study of weight loss program. 4 subjects lost an average of 45 pounds. It is found that there is about a 23% chance of getting such results with a diet that has no effect. No, let me make sure that sentence makes sense. In other words, what they're saying is, these 4 subjects, that's a lot of weight they lost, but it's found that there's a 23% chance of getting these results with a diet that has no effect. That sounds like a funny thing to say. How can you do a diet that has no effect when you lose 45 pounds? I don't know, it's kind of a funny question. But anyway, what they're wanting you to see is this 23% chance. What is that? That's luck. That's the chance of luck. That's more than 5%. Right. So they're saying, hey, could it have been the diet? Maybe, but there's a 23% chance that it was, just whatever. They were doing something else that made them lose weight. So that's not believable. You shouldn't put your confidence in those results because there's just too big a chance. Now, you might think, well, 23% chance, that's not more than 50, right? But it could be that weight loss program is really good. But we just don't have strong enough evidence yet to really trust it. You understand what we're saying? We're not saying it's no good. We're just saying there's not enough proof yet. 23% chance of luck is just too much chance. It could be just those were people that were going to, start exercising more or whatever. It could be it was something else There's a 23% chance it was something else. It wasn't the,
Metabolism.
what's that? Yeah, something changed in their life or whatever. So, does it have statistical significance? No. Wait, there's two no's though. No, it's not, because the results are likely to occur by chance. And it says unlikely to occur. Yeah, the results are likely to, it could be chance. They shouldn't use the word likely. That's actually, likely means more than 50%, but whatever. I know what they mean. So, it's just too light. It's possible. All right, let's go on. Does the weight loss program have practical? So now we're distinguishing. The purpose of this question is, did you get the difference between statistical significance, see it up here? And then down here, we're talking about practical significance. Remember what that difference is? Statistical significance is the chance of luck, right? Practical is, does it matter? Does it matter practically? Like, the girl, 52% chance of girls just isn't much of a practical difference. So is the weight loss one matter? Is it practically significant?
No.
How much weight did they lose?
45 pounds.
That's something, isn't it? Don't you think? If I lost 45 pounds, you'd notice. Right? So 45 pounds is a chunk. Right? So that's significant. Is that making sense? That's practically significant. It's practically significant. So, yes, it has practical significance because the amount of lost weight is large enough to be considered significant. Right? We wouldn't think that, if somebody said, hey, I got this weight loss program, on average people lose 45 pounds, you wouldn't say, oh, that's nothing. 45 pounds, that's something, right? On that. What was the other yes there? Yes, the program is because the results are too unlikely? No, so it's that. Am I making sense? All right. So number 10. So in a study of a gender selection method used to increase the likelihood of a baby being born a girl, they all want girls. 1964 users of the method, 1,000, I read that like a year. 1,964 users of the method gave birth to 966 boys and 998 girls. Let me write that a little bigger for you. So 966 boys and 998 girls. There's about a 24% chance of getting that many girls if the method had no effect. So what does that mean? Let's go on down. They want you to fill in words. So the way the homework will work is they got 3 blanks. Well, 4, I guess. 4 blanks. And, no, I guess it's 3. Yeah, 3 blanks, 4, and then a percentage. Okay. So, and then here's the options for what goes in the blanks. So the first one, let's read it. Because there is a 24% chance of getting that many girls by just luck, right? Understand what they're saying? You can have a treatment that really is not doing anything. And the people just have their babies, and you get a few more girls than boys. It's not that many more. That could have just been luck. In fact, there's a 24, that's what we'll learn to calculate later. There's a 24% chance that was just luck. It wasn't really the treatment making that happen. It was just random luck. So if there's a 24% chance of that, the method is what? Which of these?
Does not have a significant.
Does not have what kind? Statistical. Does not have statistical. So again, statistical significance is the luck thing. So does not have statistical. Does not have statistical significance. Is that making sense? Statistical significance is the chance of luck. It's too likely it could just be luck. Next blank, number 2. Not many or most couples would likely use a procedure that raises the likelihood of girls from 50% rate expected by chance to the percent produced by this method. Yeah, I'm not sure what they want me to say there.
I don't think
Oh.
You don't fill in the.
percent.
Yeah. No, we'll get to the percent in a minute. But we're actually doing this option right now. We got to fill into here the words not many or most.
It's the same thing, right? Not many, most.
Yeah. Well, not many would be, just a few, and most would be a lot. So, so this one's going to be most. Do you see why? Most couples would like, oh, no, not most. It's not many.
It's not many.
Yeah. Am I totally confusing you? Am I helping? Maybe if we read on, it'll be helpful. We'll come back to this. It's going to be not many, but here's why. Not many couples would likely use a procedure that raised the likelihood of a girl from 50%, approximately, expected by chance, right? 50% chance at random, to the whatever percent produced by this method. Now, what is the percentage chance? This method produced 998 girls, 966 boys. What percentage girls came out? Could we figure that out? No, 24% was the chance. It was just luck that
You
happened.
gotta divide 966 into 998.
No.
What do we got to do? What does percentage mean? If I said, hey, what percentage girls came out? 998 girls, 966 boys. What percentage were girls? How do we figure that out?
Add them together and divide.
Yeah, whenever you do percent, it's part of the whole. You got to put the bottom. So the percent girls is going to be the number of girls divided by the total number of girls plus boys. Huh? Is that making sense? Can you read my scribble in there? Kind of got it.
1964.
Yeah, so let's figure that out. You guys have your calculator. This is why you want to use a calculator. I mean, just a regular calculator can do this, no problem. So the percentage of girls is going to be the number of girls, which are 998, over the total 966 plus 998. What is that denominator? 1964? Oh, yeah, they said that up here. Yeah, that was dumb. Yeah, sorry. Yeah, you didn't have to add those. They gave me that already. Yeah. All right, so anyway, so on your calculator, divide 998 by 1964. Somebody got a number for me? 51? Yeah, plus blah, 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 blah. Oh, yeah, I don't know how many they want me to round to. What is it? Oh, round to the nearest integer. So what is it? 51 point what? 51.508? Oh, it's, gotcha. 50.8? So that rounds to 51%, doesn't it? So that's right here. So 51%. So yeah, so would people want to do that if they said, hey, you can raise the chance of having a girl from 50 to 51? No, now we know it's clearly not many, and it's not practical. Yeah, that means it's not practical, huh? So you see, this study is both not significant, statistically significant, and not practically significant either.
If it would have been like 80%, then it would have been maybe practical.
Practical, yeah, right. So everybody see that? This one fails on both accounts. Does everybody see that? It fails to be statistically significant because the chance of luck is just too high.
24%.
Well, where is it? Yeah,
24%.
lost it somewhere. Oh, there it's 24%. Yeah, and then it's not practically important either because it only raises it up to 51%. That's only 51% girls. So it fails on both accounts, doesn't it? So that would be our answer down here. The method does not have practical significance either. Good? This making sense? All right. Let's move on. Number 11. Refer to the table of body temperatures. Is there a meaningful way in which each body temperature recorded at 8 a.m. is matched with the 12 a.m. temperature? It's kind of a weird question. It's like we're changing gears here. So we got to finish this up. All right. So let's see. Let me see how many questions we got here. I want to make sure I finish in these next 8-9 minutes. 24 questions. What number were we on? No more fooling around. All right. Number 12. Wow, I didn't have so many. So, all right, so what's going on with this? Well, basically, wait, is that the right question?
We were not.
Yeah.
11.
Trying to skip questions.
I'm trying to skip them. Okay, here we are. Yeah, notice, I'm just going to kind of speed up a little bit here, I guess. Notice the word subject. So that means this is subject number one, person number one. This is his or her body temperature at 8 o'clock and their body temperature at 12. This is person number two, their body temperature at 8 and their body temperature at 12. So is there a meaningful way in which the 8 a.m. and the 12 a.m.s are matched? Yeah. It's a person's body temperature, right? This matches with this in a meaningful way because it's the same person, right? That's what they're wanting us to see. That's the same person, their body temperature at 8 and 12. How do I know? Because it said subject. So yes, the 8 a.m. temperatures are all from one individual. No, that's not it. Yes, each column of 8 and 12 is recorded from the same subject. Yeah. Yes, let's see what's wrong here. The 8 a.m. temperatures are all from one individual. No, they're not. That's crazy. All right. Let's move on to number 12. So same thing there. Oh, no, actually, it's not the same thing. Refer to the sample body temperatures in the table below. Given these temperatures, what issue can be addressed by conducting a statistical analysis of the data? What issue? I don't know. Let's just read it through. The data can be used to find the percentage of people whose body temperature increases with illness? Doesn't seem like it. The data can be used to address the issue whether there is a difference between average body temperatures for males and females? No, we don't know anything about whether those are males or females. The data can be used to address the issue whether there is a correlation between average body temperature and a person's exposure to sunlight? No, there's nothing about sunlight in there. The data can be used to address the issue whether there is a correlation between body temperature at 8 and 12. Yeah. All right, so these are kind of silly questions. I'm probably moving fast now, huh? So let me see. I want to make sure I cover all the ones that are hard. That's 13. IQ score and brain volume, like how big your brain is and what your IQ is. Are those related? Do people with bigger brains have higher IQs? Or do they not? That's what this is. So here's subject number one. That's the IQ score. That's the brain size in cubic centimeters. And subject number two, there's the IQ score and the brain size. So does it make sense to use a difference between them? They're saying, should we subtract those? Would that be a good thing to do? In other words, should I take 101, for this person, subject number 5, should I take 101 and subtract 1075 and get whatever that number is? That would be meaningless. That's what they want you to see. There's no point. Now later there will be things we subtract. They'll be meaningful. But that makes no sense because they're different units. They're not even, it's like apples and oranges. You know what I mean? It's IQ score, whatever that is, and then cubic centimeters. I mean, why would you subtract those? That makes no sense. Or add them or do anything like that with them. They're like totally different things. Even they might have a relationship, but they're not to be added or subtracted. Is that making sense? On that, you wouldn't want to add, or what would it even be? What if you subtracted those and got negative 912? I was guessing. What would that be? 912 what? What is that? I mean, that's just meaningless, right? That's just silly. So I'm going to move on. It's one of those no's, but I want to get through the other questions for you. So in the data table below, the X values are the weights of cars, and the Y values are the highway fuel consumption. So this is the weight of a car, and it's miles per gallon. Weight, miles per gallon. Weight, miles per gallon. Given this, what issue can be addressed? Does the highway cause the weight to increase? No, that's backwards, huh? Is there a relationship or an association between the weight of a car and fuel consumption? Yes. Yeah, that's it. More a car weighs, it tends to be less efficient. We'll move on. 15. In the table below, the X values are the weights, and the Y values are the fuel. Same thing again. Comment on the source of the corresponding highway fuel consumption. Comment on the source of the data. If you are told that the car manufacturers supplied the values, yeah, there's, I'll let you answer that one. That one's easy. If the car manufacturers were involved, they're biased, right? They have a motive to make things look more fuel efficient. I'm going to move on. Several studies showed that after drinking coffee, subjects had increased blood levels of antioxidants. Antioxidants have been associated with decreased risk of heart disease. A coffee company financed this research. That's easy. I'm going to move on. 17's at the bottom there. Magazine ran a survey downloading music. The readers could register their responses on the magazine's website. Identify what's wrong. What is it? Oh, it's voluntary again, isn't it? Sample is voluntary. Let's move on. 18. Polling company reported that 53% of 10-18 surveyed adults said secondhand smoke is quite annoying. Complete A through D. What is the exact value that is 53% of 10-18? Do you know how to figure that out number-wise? How do you find 53% of 10-18? Of 10-18. How many people is that exactly? 53% of 10-18. What do you do? Yeah, multiply. And what do you do with the 53%? 0.53, right? That's why the decimal goes back 2 places. Times, 10-18. Somebody have that in a calculator? What's 0.53 times 10-18? 539.54?
Yeah.
Thank you. All right. Could this be the actual number of adults that said secondhand smoke was annoying? How many said that? 539.54. Yeah, that it can't be part of a person, right? So what that means is no, it can't be because so they have you go on down, you're going to say one of these no's. It could not be the actual number because because it's D. It's not B because it says very rare opinion. That's not the reason. It's D because a count of people must be a whole number. Can't have part of a person, right? C, what could be the actual number? So if it's not 539.54, how many people actually said they thought secondhand smoke was quite annoying out of the 10-18? 540. Yeah, you just round it, huh? Must be 540 actual people. And so that's an easy question. Let's try to finish these up here. Polling company reported 27%, 2302, blah. That's the same kind of question. Yeah, so that's easy. I'll move on. An ad for a device used to discourage bike theft said the device reduces your odds of bike theft by 250%. What do you think about that? What if you reduce it by 100%? What does that make it? That's the whole thing. How can you do more than 100%? That's bogus, isn't it? That's baloney. You can't reduce something by more than 100%. That's baloney. 100% is all of it, right? If you reduce by 100%, you took it down to 0, right? That's baloney. So the device, the actual amount decrease in bike theft is less than 100%. You can't go by more than 100%, which is not a voluntary response. I'm sure you can do that easily. 22, what does it mean for findings of a statistical analysis to be? Yeah, these are all easy practically. We went over that. 24, loaded. Yeah, I think that'll be easy. Questions that trigger. Choose the correct answer below. Worded to elicit a desired, yeah. So it's B. Intentionally worded to elicit a desired response. All right.